Let's look at our cosine function. So this time, remember, some of those numbers that we did for sine are switching. So the cosine of 0 is 1, right? And the cosine of pi 6 is that square root of 3 over 2. So what was that? 0.86. And then the pi fourths, cosine of pi fourths, is the same as the sine of pi fourths. So that is still 0.71 or whatever that decimal is that we got. Square root of 2 over 2. Pi thirds is now where cosine is 1/2 because sine and cosine are opposite with those numbers because they are cofunctions, right? They're complementary angles, and so their sines and cosines go opposite. The cosine of pi halves, the x value is 0, so the cosine is 0. Okay, don't forget, all students take calculus. Tell me about quadrant 2. That's quadrant 1. We're on to quadrant 2. What is cosine in quadrant 2? In general, it is negative, right? So our reference angles are going to have the same values. So pi thirds and 2 pi thirds will both be 0.5, but in quadrant 2, it's negative 0.5 because it's cosine. Quadrant 2 is going to be negative 0.7. Quadrant 2 is going to be negative 0.86. And pi is going to take us down to negative 1. Let's see what we've got so far. So let's graph these points. We've got a point at 0, 1. We have a point at pi 6, 0.86, so somewhere up here. We've got a point at pi 4, so remember that's halfway between pi 6 and pi thirds. So that'll be at like 0.7, so somewhere in here. Pi thirds is 1/2. And then all of a sudden at pi halves, it goes clear back down to 0. I'm not sure that I put those points in the right place to create the curve that I want it to be. And then I curved it more than I wanted. It'd be better if my grid had better values on it. I give up. I don't think I'm supposed to graph this right now. Maybe I'll do it on my smartboard instead of on my tablet here in a second. Okay, so now let's do these negative values. So 2 pi thirds went down to 0.5, negative 0.5. Halfway in between goes somewhere in between. 5 pi 6 goes somewhere in there, and then pi goes back to, or goes up to, or down to negative 1. So we should end up, let's see if I can sketch it this time a little better. I missed my pi halves, but I sort of got it. Okay, quadrant 3. Cosine negative or positive? If you said negative, you're correct. So that means 3 pi fourths and 5 pi fourths are the same number. So that would be right in here. It's going to take us to about right here. Right, so this is heading back down, or back upward towards the x-axis, sorry. 3 pi halves, it's going to be the same as pi halves. The x value is still 0, so we go up to 0 here. And then 7 pi fourths, cosine in the fourth quadrant goes back up to positive. So that's going to be a positive 0.7. Around right here. No, that's the wrong place. It's more like here, I think. And then 2 pi goes back up to 1 again. And then if we go to our 9 pi fourths, just a little bit past, we might discover that it's just going to repeat the process, right? Because that's going to come back down to 0.7 and just repeat all over again. So here we've got our fundamental cycle again from 0 to 2 pi, just like we did with sine. However, sine started at 0, went up, went through 0, went down, went to 0 again. That's our one cycle, right? Whereas cosine starts at 1, goes down to negative 1, and then goes back up to positive 1. That's our fundamental cycle instead. Otherwise, aren't they the same graph? It's really honestly the same exact graph, just shifted over. It just starts a different place. It has a different y-intercept. So in that regard, we've got about the same thing. Let's go through the properties. I have another card for you. I'll get it to you in a second. Let's finish this video first, if you don't mind. All right, our properties for the cosine graph. First of all, let's talk about its symmetry. So this one has even symmetry. Isn't that interesting that we have a graph that's pretty much exactly the same shape as the sine graph? It's just, it starts a different place, so it's just like shifted over, and yet it has a completely different type of symmetry. Because if you imagine the graph continuing off this direction to negative pi halves, this does not look the same upside down, but it is the reflection of itself over the y-axis. That's what even symmetry looks like, right? It's like a parabola. A parabola has even symmetry, just like a cosine graph does. Okay, so we have our even function. The domain and range are exactly the same as they were for sine. So domain is from negative infinity to positive infinity. Range, again, the adjacent side is less than or equal to the hypotenuse, so range goes from -1 to 1, just like sine. The period is still going to be 2 pi. The amplitude is still going to be 1. The midline, I should add those things to these cards. I forget, but it's okay. I don't know if you need them. The midline is the x-axis. So there's some other little details that aren't on the card, but if you want them. And then our key points would be our intercepts, which are at pi halves 0, 3 pi halves 0. You might think, oh, can we just say k pi halves 0? Well, not really, because k represents all integers. So what if k is an even number? Then you would have like 2 pi over 2, which is pi, and there's no intercept at pi. It's a maximum. So when you do it, just to kind of give you a heads up on how to write it that way, it would actually be like pi halves plus k pi, because they're still a pi distance apart. They just aren't at 0 anymore. It's at like pi halves, and then all pi halves values bigger or smaller than that, but those are all going to be a distance of pi away from each other. So that's how to write the infinitely many intercepts. Okay, so then our minimum is at pi -1. And our maximums, there would be 2 of them in our fundamental cycle, would be at 0, 1, and 2 pi, right? So again, we have our 5 key points that we can use to sketch our graph and make any modifications to it, transformations to it that we need to. But as long as we understand those 5 key points, we'll be able to sketch in that graph from those points, just a curved graph through the points.